Hi, everyone. Welcome to the NG-SDN track. Let's get started. So our first talk today is on Stratum. So I'll be, over the next 30 minutes or so, providing just an overview and a project update, and helping to set the stage for the rest of this track. So just a quick overview of what I plan to cover in the next 30 minutes or so. The first is just cover some of the Stratum basics. Also, I'm going to talk a little bit about the open source launch you may have heard about this morning or yesterday. A little bit of the project roadmap. Then we'll also just provide a quick preview for the rest of the session today and later this week. And then just briefly, I want to touch a little bit on the community that's helped make this project happen. So first of all, let's just answer an easy question. What is Stratum? And a short answer for you there is it's an open source, production-targeted, thin switch OS that implements next-generation SDN interfaces and models. So what are these? We start with the control and management plane interfaces of P4 runtime for programming ASIC state, GNMI for configuring both ASIC and platform hardware, and GNOI for doing in Stratum are defined using P4 programming language, and you'll instantiate a P4 program and push it down to your hardware device. And then finally, for conformance and compliance tests, we're building out a repository of test cases we call test vectors. But Stratum's an implementation. So under each of these interfaces, we have a number of components that work together to realize these things on hardware. On the right side of our picture, we have an abstraction layer we call Stratum Switch Interface or Switch Broker Interface, which provides a common interface under which platform-specific code can plug into the common implementations of P4 runtime, GNMI, and GNOI. In the green boxes on the right, we have the code that's responsible for taking P4-related objects or GNMI-related objects and transforming those down to Switch SDK calls. And these are going to be platform-specific. We also have code that manages the chassis, things like the serialization, deserialization parameters, as well as the front panel to ASIC port mappings, as well as APIs and managers for managing the platform pieces, things like your fans, your SFP modules, power supplies, et cetera. Our platform manager is built on top of Open Network Linux Platform API, and this is what plugs into the peripherals that are going to be provided by your white box vendor device. To make the programming side work, we also need a P4 compiler, which takes the P4 code and turns it into a runtime format that Stratum can consume, which enables us to push rules down and ultimately enable traffic to flow at runtime. So our P4 compiler with Stratum is we provide a fixed pipeline compiler targeting Broadcom ASICs. We also use a closed source compiler from Barefoot Networks for a Tofino ASIC. And we have a compiler for BMV2, a software switch we'll talk about later. Once you have an overall Stratum solution, we need to make sure that that solution is compliant with the interfaces as a control plane would expect. And we have, as I mentioned before, test cases called test vectors. We also have a runner framework that you can use to make sure that the device you want to put under test conforms to the APIs as an external entity would expect. So the next question you might be asking is why Stratum? Why do I need it? Why did you build it? And I think what it comes down to is really the interfaces. So Stratum provides SDN-ready interfaces that were built from today's SDN and are optimized for the next generation of networking going forward. The value prop here is hardware independence and vendor optionality, which largely comes from our common model definition and top-down programming paradigm. APIs that support automated full lifecycle management and operation, so you can have computers that are managing your devices rather than humans that are logging in and operating them. This goes hand in hand with something called zero-touch provisioning, an ability to bring up a device without a human interacting with it, having a system generate the configuration and the pipeline and push that down, get things started. So the only human interaction is literally putting the box into a rack and plugging in cables. And finally, these APIs give us the ability to program the data plane and agility to move forward with features that you, the operator of your network, or you, the user, want in your network today. You can do things that matter to you. You can scratch your own itch. You don't have to wait for someone else to build it for you. To cover how we achieve top-down data plane programmability, I thought it would be helpful to look at a simple example. So we start with a P4 program. This is where we define the headers, the parser, and the forwarding stages that are required to process packets in a pipeline. Here we have a simplified pipeline where we have a MyStation table or routing classification table, followed by either an IP routing table with ECMP or L2 forwarding, followed by an ACL table where we might redirect traffic, drop it, or do packet ins. This gets compiled where we generate our runtime contract or P4 info file. And then it also, the compiler's job is to push this down to the backends, like the FPM backend we have for Broadcom or the Tofino backend for Barefoot. And this is where we allocate the resources to realize the pipeline, as well as generate the runtime mapping from our contract down to the data plane SDKs. We get a binary output from the compiler for those. This contract, or P4 info, plus the binary output, is fed into our control plane. The contract goes to the control plane and the P4 runtime server. And then the resource mapping goes down to the switching ASIC. We do some initialization, and then the target driver manages runtime mapping of rules coming from the server. To communicate between the control plane and data plane, we use something called P4 runtime, which is a gRPC-based service defined in protobuf, and is largely work that was evolved from the OpenFlow specification. On the platform-independent side, we start with two things. One is we start with a set of OpenConfig models, which are Yang models that are used for describing both configuration and telemetry state that can be retrieved from a networking device. And we also start with Open Network Linux, where we have a platform API that a lot of vendors have done a lot of work to port their platforms to it. What Stratum does is twofold. First is we compile the Yang models into a format that Stratum can understand, into protobuf objects. And then we have a mapper that manages our interface to the control plane, as well as translates that down to our platform manager, which works on top of ONLP. So at its core, we have a configuration mapping subsystem and a configuration database. The database manages our in-memory view of the current configuration state. And the mapper is responsible for translating from the OpenConfig paths through our platform manager down to our platform APIs. On top of this, we have GNMI, another gRPC service from the OpenConfig working group. And control planes or orchestrators can connect either locally or remotely through this interface. The next thing is Stratum's been built in a cloud mentality. And it's designed to support cloud-style agility. So this means, typically, using deployment and testing frameworks that enable best practices in CI/CD. The other thing that's important to enabling cloud-style agility, as Nick alluded to earlier in his keynote, is you need telemetry so that you can collect state from your network so that you can do end-to-end verification and closed-loop control. Most importantly, initially, is failure detection so that you know when to roll back if things aren't as expected. So we start with our source code, which could be in GitHub or a private repo. We work it through a CI tool, like Jenkins or Travis or Circle CI, who's responsible for running unit tests and static analysis, building Docker images, and then running conformance tests. These are where test vectors get run on top of a Stratum-based switch. After it passes CI, it may go through a few additional qualification steps, but ultimately it'll be deployed to the network. And we can deploy it to the network using the same practices used to deploy containers to cloud infrastructure today. We can have an orchestrator, like a Kubernetes, that pushes these Docker containers to our switches, brings them up, and then the control plane can collect telemetry to determine whether or not the box is behaving appropriately. If not, roll back. If so, move forward. Ultimately, this helps us close the loop so that you can deploy to network, you can learn from your experience, you can write more source code, and run this through a pipeline in a fairly rapid and iterative fashion. In terms of testing, I just wanted to cover test vectors. This is work that was presented by Google last year and will also be presented tomorrow in more detail. But just to set the stage for test vectors, the first part of them is they serve as compliance tests for Stratum-based devices. Stratum, from the perspective of a test vector, is a black box. So the only interfaces it's interacting with are its northbounds, P4 runtime and GNMI. Test vectors can either manually be written by humans in protobuf format, or you can use higher level languages to semi-automatically generate these things. And we have an example of an automated language for generating test vectors called cdlang. You can also generate these test vectors automatically, either by analyzing your programs, or by analyzing your models, or by taking traces from your production network and simplifying them into a test case. So all of these form a repository of test cases that can be used to qualify boxes. So what does a test vector actually look like? It's a protobuf that has a set of stimuli, things you want to do, either externally to the box, like sending a data plane port or writing a new flow rule, and then expectations. I expect this data plane packet to appear somewhere else in my network, or I expect a port counter to be incremented, something like that. So part one is building a repository of test cases. Part two is running them. And Stratum is also working on a data-driven test framework we call Test Vectors Runner that enables users to execute these. We have a reference implementation of this runner in Go, and it's currently supporting P4 runtime and GNMI. The Test Vectors Runner we'll learn about more tomorrow in much more detail, but at a high level, it communicates using the gRPC interfaces to the device under test, as well as to a traffic generator that can generate and receive traffic from the data plane ports of the device. So the next part I want to talk about is the open source launch. So as of this week, Stratum's been approved by its community members and TST for open source, and is going to be hosted on GitHub under the Stratum organization. What can you do to get started? So if you want to get started with Stratum, there's a quick, easy 30-second step. You can execute Docker. We can run, for example, a container containing a software switch called BMB2. We'll run this with input enabled and a pseudo terminal. We'll map a port out to our host machine so we can communicate with the device, and the image is already public. As you can see, Docker is going to run through pulling down the various layers that have all the dependencies precompiled and included, and then is going to start a mininet network with a single switch. You can add more mininet parameters if you want a bigger topology. But we have a single switch that's going to come up running Stratum with all of the interfaces on its port 5001. So if you want a basic tutorial, just how do I get started, how do I run this myself, you can either type those commands that we just did at the top of the slide, or you can visit the tutorial repo with a few instructions on how you can run this on your laptop. The only dependency is going to be Docker. This also works for hardware switches. So on hardware switches, the one thing I'll note is that the canonical port for Stratum is 28,000. We haven't gotten this approved anywhere, but this is what we've used on most of our hardware switches today. And if you want to use it, you just need to make sure that you mount in things like /dev/sys and the ONLP libraries into your container so that Stratum can find the physical hardware devices, the peripheral I2C devices, and the platform libraries. So what should you expect if you go and download Stratum today? Well, this is an alpha release, meaning that we have a software architecture in place. We have initial support for fixed function and programmable targets, but some features are not there yet. The community is actively working on the project, and we're currently building out a full set of support for the northbound interfaces and a full set of support for the open config paths. But today, you can use Stratum for demos. As you can see in the show floor, we've done a number of demos here at ONF Connect, as well as in previous events over the past year. And it's also ready for user experimentation and for porting new platforms. We have a model now for both fixed function and programmable platforms from the ASIC side and platform side to be brought to the Stratum architecture. And if you just want to get started in your lab, for example, it's ready for consumers or operators to start playing with it. One of the other big advantages of our open source release is we're changing the licensing model from a proprietary license that was largely used while the project was in incubation to Apache 2.0. So now Stratum is something that can be incorporated into vendors' products, and we're expecting that vendors, given the appropriate production opportunities, will go through a significant hardening of the platform to bring it beyond alpha. In terms of switch support today, we have support for 2 different ASICs, Barefoot's Tofino ASIC and Broadcom's Tomahawk ASIC, on boxes from 6 different ODMs. We also have support for 2 software switches. One is a BMV2-based switch. This comes from the P4 community, and it's a P4 software switch emulator that can pass real traffic. We also have a dummy switch, which you can use if you want to do some testing of the APIs. In the near term, we have a number of members of the Stratum community that are working on getting their boxes ready and ported. There are existing boxes, or there are new boxes from existing vendors, as well as new vendors that are bringing new boxes. We're also expecting some support from Mellanox on their Spectrum ASIC, as well as some non-x86-based platforms as well. That's a great question. So who's done what, right? And if we go back to the architectural diagram, on the chip mapping side, a lot of that work's been done by the ASIC vendors. On the platform side, a lot of the work's been done by the ODMs. And then Google and ONF Google largely seeded the project with their source code, and ONF has largely helped glue some of these pieces together and make sure that the platforms are running together. So the question's about which P4 programs are supported. And the P4 programs that you can write are going to be target dependent. In our demo that I'll talk about later, we're actually using the same P4 program, which is a L2, L3, ACL, pretty simple table. Same program on both ASICs. Actually, same programs being compiled by both targets. But obviously, you have to look at the target specific to understand the specific target to understand the features that you can expose through a P4 program. So in terms of downloading Stratum, the easiest way to get started is to download the Docker images. So the Docker image we showed in the Getting Started tutorial is a Mininet-based image with the BMV2 switch packaged in. So that's on Docker Hub today. We've also published a Docker image for Tofino running Barefoot SDE 891 and the Linux kernel 4.14. That's available today. We're putting the finishing touches on a Tomahawk-based Docker image. And then if you don't have the ONL, so the Tofino and Tomahawk images both run an ONL. And if you don't have an ONL image today, you can either build it yourself from source. We have just a fork of Open Network Linux in an Open Networking Labs repo that we use, or we'll be making a pre-built image of this available soon. And just something to note about ONL is we're using their new V2 APIs. In the OCP community, they've been talking about migrating from the original ONLP APIs to a second version. And a lot of that work has been kind of pushed and motivated by Google and the Stratum community. The next part of the open source release is, how can you start to engage? And the thing that I'd recommend for folks that want to get started is to try out the basic tutorial first. Second is we use GitHub for source management, issue tracking, and pull requests. So if you have bugs that you're observing, you want to request features, or you want to submit patches, do so via GitHub. We're still in the process of getting all the mailing lists set up, but we do have an announcement list in place today. So sign up for the announced list. And in the next couple days to weeks, there'll be more details about things like the project calendar, dev lists, and how to join Slack. And lastly, I'd encourage you, if you're interested in kind of understanding how things are running on a more day-to-day basis, to attend the weekly technical steering team calls, which we have oscillating between Wednesdays and Wednesday afternoon and Thursday mornings to accommodate people in different time zones. So our next question that this talk is gearing to answer is what's next for Stratum? And I wanted to take a quick look at the high-level roadmap for the next months to year or so. So the first step is pushing Stratum towards production. We've cleared the open source and licensing barrier, and now it's finally something that can be supported as a product going forward. So we're currently working towards feature parity with ONF's Trellis and SEBA. You can see in one of the demos, we've done demos on Trellis and we've done demos in SEBA, but it's not fully featured yet. So there's still a few things with respect to adding support for MPLS labels, VLAN, security, QoS, and some of the operational interfaces and configuration that we're working through. Second is adding additional chips and platform. I alluded to some of those in the platform slide, but expect that now that it's open, more vendors will be able to port this to their boxes. Third is a formalization and publishing of our compliance test framework. So we're working to try to gain broader adoption for this test vectors approach, as well as increase the number of test cases we have available in the public, and build tools to make test case generation easier. Finally, we're starting to look beyond packet switches. Stratum today is mostly been targeted switches that you'd find in a data center. But we're also seeing interest in using Stratum for things like packet transponders. Leonid from PL Vision is going to have a talk at 5 p.m. today about how we're thinking about this. Stratum for SmartNICs. And then I'm not sure how that bullet went in there. But there's a few other opportunities that are kind of exciting going forward. So yeah, there's two parts to the question. The question is, what do we mean by support for MPLS and VLAN? These are things that should just be done in P4. So one part of this is writing a P4 program. And we've started work on a program called fabric.p4, which covers a lot of this. And the second part is that our FPM compiler doesn't yet support mapping to some of these things, like double VLAN tags or MPLS labels. So there's a little bit of work on the FPM compiler side to make this happen. Tofino's compiler is capable of doing this today. The last thing I want to mention about this roadmap is that this is the roadmap of the companies that have been part of the project so far and the individuals that have been working with us so far. But this roadmap for this project is something that's defined by the community. So if you have ideas or want to push Stratum in a new direction, try it in new use cases, et cetera, I'd encourage you to write those things down in either a document or presentation and take it to one of the technical steering team calls. We're pretty receptive to understanding ways in which people want to use this and trying to help enable them to do that. So ultimately, this roadmap, in 3 months or 6 months, could have other bullets that are higher priority based on the resources you want to contribute and the energy you want to put into this. So the next thing is just looking at where you can find Stratum in ONF Connect today. So this was our basic architecture picture. And if you want to learn more about the internals, how we built FPM, how we do the platform manager piece, et cetera, or how we implement GNMI config subsystem, stick around. The rest of this block is going to talk about some of the internals in more detail. If you're interested in kind of the ecosystem and some of the use cases that we're currently considering, Wednesday and Thursday in this room from 4:30 to 6, we'll have a few talks covering those opportunities. Tomorrow afternoon from 2 to 4 is all about testing and qualifying Stratum devices. And then if you're interested in kind of micro-ONOS or the evolution of ONOS and the ONF's control plane, Friday from 2 to 4 is what you should check out. So that's kind of your roadmap for this track over the next couple of days. Stratum's also being featured in 3 demos at Connect. The first is an interoperability demo. This is our community launch demo, where we had multiple ASIC vendors and platform vendors come together to build what one of my colleagues, Carmelo, calls a Frankenstein rack that's currently on display. We have 8 switches in an IP routed leaf spine fabric. And this really highlights some of our abilities for hardware independence and full lifecycle operation. Stratum's also being featured in the micro-ONOS demo, where we're doing zero-touch provisioning on 3 Stratum devices. And then in the SEBA demo, we're highlighting top-down programmability by offloading the BNG functionality to a Stratum switch. Just wanted to give you a quick rundown on the interoperability demo. So as I mentioned, it's a leaf spine fabric. We have 5 leaves and 3 spines. We've got both Tomahawk and Tofino boxes in both roles. We're connected to the internet via an upstream router, and we have a port connected to our laptop, as well as hosts connected to servers that can be used to generate traffic. And this was a big effort from a large number of community members to get this up and running. Other opportunities, if you were here yesterday, we had a tutorial on NG-SDN where you got some hands-on experience running Stratum. If you missed it, the tutorial's online. The code's there. Videos will be available soon, and the slides are also available via this link. I'd encourage you to check that out if you're really looking to get your feet wet, so to speak, like 40 or so people did yesterday. There's also going to be a keynote tomorrow with Nate Foster from Cornell, Timon Sloan from ONF, Thomas Wachowska and myself talking about the overall picture for Next-Gen SDN. So the last thing I wanted to talk about a little bit is the community. And as I mentioned, this is an open source project. Open source projects live and die by their communities, and we've started to see a really big effort come behind the Stratum project by a number of different participants. So we started out with a set of launch members back in March of last year. And what we've seen is that we've gotten a steady stream of vendors, new operators, solutions providers that have come in and really had a plan about how they wanted to use Stratum, either port it to their box or use it in some use case. That plan was approved by the community, and they've largely helped push Stratum to where it is today. The other thing is I wanted to take just a moment to recognize all the individuals that have contributed code to the project so far over its last year and a half or so. These are the people actually doing the work to make this happen, and you'll see kind of a nice collection of people from different operators, different vendors, et cetera. There's also a number of people I know that kind of get hidden under the commit log. They're co-authors to commits. A lot of this code also came from Google, and so there's a number of anonymous contributors that were working tirelessly behind the scenes to get the platform into its current state. And the last thing I wanted to do is just talk about a new award that the ONF is starting this year. It's called the Contributor Award, and it's given out to individuals that have been recognized by their peers as top code contributors or code removers, people that have been mentors or reviewers for the community, people that have been ambassadors or advocates for the projects, have contributed significantly to one or more components in the system, or they're just constantly helping everyone be more productive. They're chopping wood and carrying water, to borrow from the Kubernetes community. So this year's recipients of the ONF Contributor Award for their contributions to Stratum are 4 individuals. The first is Ali from Google. He's sitting here in the second row. So we have a coffee mug and and a certificate. Oh wait, this is DevJit's awards. Thanks. The second is Antonin Boss from Barefoot Networks for his contributions while he was at Barefoot. The third is Devjit Gopalpur from Google. And the fourth is Yi Singh from ONF. So Yi's right here. So these individuals, I mean, Ali and Devjit from Google have really been the community ambassadors. They got the code ready for the incubation partners, and they've been really driving forces behind the architecture of the project from the start. Antonin, you may know from the P4 community, has done a lot really to promote P4, co-chairing the P4 runtime working group, and also getting his hands dirty and porting this Stratum project to BMV2 and Tofino. And then Yi, most of you who have tried to port a box to Stratum today have done so with his help. He's done a lot on the configuration side and on our platform manager side, and also really helped get the demo running and get a lot of the platforms to a point where they were working with Stratum. So just a quick round of applause again for our outstanding contributors. No, it's okay. The other thing is, so if you've contributed code, your name was on this slide, and somehow you don't have a shirt yet, come find me, either after this talk or in the break, and I've got a T-shirt to thank you for your contributions. So with that, I think this talk is done, and we can get on with the rest of our program. So thank you.